friends, good evening. Today we are going to discuss with another coordinate system, that is spherical polar coordinate. Last class we seen what is Cartesian coordinate system, right? How we represent areal element, volume element and length element in Cartesian coordinate system, right? So similarly there we seen to discuss about a particular point in a three-dimensional Cartesian coordinate system, we require 3 points. One is x, another one is y, another one is z, right? Similarly, to represent a point in spherical polar coordinate system, how many points we required, right? Here also, suppose I am considering this is the axis of the sphere. For the time being, I am representing a sphere like this, right? Suppose this point is on the surface of the sphere, right? This point P is on the surface of the sphere, alright? Then to represent this particular point, we need this radius vector, right? This is the radius. And about the axis, it makes an angle theta, right? Theta. And then see this angle phi. Suppose you draw a perpendicular to this point P, and that particular point P, right? That perpendicular that makes an angle phi with the x-axis. Phi with the x-axis. Now think about it. If you consider a point on the surface of the sphere, suppose you give the value r theta phi. Only one point on the surface of the sphere only we can represent using a unique r theta phi, right? So once we define r theta phi, right, about a point, then that particular point only exists for that particular r theta phi value, alright. So instead of x, y, z, here you can use r theta phi as the coordinate system, right. Now another thing is, you studied in Cartesian coordinate system x, y, z. What is the angle between different axes? 90 degree, right? X-axis, y-axis making 90 degree each other, y-axis, z-axis making 90 degree each other, z-axis, x-axis making 90 degree, right? Similarly, look here, suppose this theta, this theta is increasing in this direction, right? So this is the theta. So if I draw a parallel like this, so theta is increasing in this direction. So that is why theta, I put theta cap, theta increasing direction, unit vector along the theta, right? Theta cap, alright. Now which direction phi is increasing? Look here, in this direction, alright. In this direction means, that means it is increasing in this direction, alright. That means it is increasing in this direction, alright. Phi cap, right. Now radius. Think about radius, how radius is increasing. Radius is increasing in this, like, so it is increasing like this. Now think about r cap, this angle is 90 degree. This angle also 90 degree. And this angle also 90 degree. That means, like Cartesian coordinate system, different axes making an angle 90 degree between them. Similarly, in spherical coordinate system also, different coordinates, that r theta phi makes an angle 90 degree between them, right? That is very important, that this shows, alright. Now we have to define what is x coordinate, what is y coordinate, what is z coordinate in the spherical polar coordinate system, right? So again, see, look here, this is our r, right? This is our r. Then if this is r vector, what about this? If this angle is theta, this is r cos theta, right? Using trigonometry, I can write this as r cos theta. And then this perpendicular to, this is the adjacent component r cos theta, the opposite component that is r sin theta. Alright? So this is r sin theta. Suppose r sin theta, I am writing p, okay, is equal to another vector p, right? Now what I can write about this? This angle is phi. Then this is some r sin theta over p. Can I write this as p cos phi? Definitely, right? This is p cos phi, and then this is what p sin phi. Alright, because this vector is p. P is r sin theta. Alright. Now this p adjacent component is p cos phi, and the opposite component is p sin phi. Now tell me what is x? See, this is x, right? So x is equal to p cos phi. X is equal to p cos phi, right? That means what is p? P is equal to r sin theta, right? P is equal to r sin theta. Then r sin theta cos phi. Alright? Now next is, what is y? This is our y direction, right? Then what is y? Y is equal to p sin phi, right? Then what is p? P is again r sin theta. Then r sin theta sin phi. Alright? Alright. Now what is z? Z is, z you can directly write it. Z component we got as r cos theta. R cos theta. Right? Alright. So from the discussion, how we represent the x, y, z? This is our x, this is our y, this is our y, and this is our z. Alright? Then x is equal to r sin theta cos phi, and y is equal to r sin theta sin phi, z is equal to r cos theta, right? So x is equal to r sin theta cos phi, right? Now let me write again. X is equal to x square plus y square plus z square I am finding. X is equal to what? R sin theta cos phi. Then r sin theta cos phi whole square plus what is y? R sin theta sin phi. R sin theta sin phi the whole square, right? Now z is equal to r cos theta. R cos theta whole square. Alright. Now what is the resultant? I can take r square sin square theta from the first two term, then cos square phi plus sin square phi 1, here r square cos square theta remaining. Again I am taking r square, then sin square theta plus cos square theta, again 1. That means r square is equal to this x square plus y square plus r square, right? Sorry, z square. Then r is equal to square root of x square plus y square plus z square. See, this modulus of the vector in Cartesian coordinate xi cap plus yj cap plus zk cap. What is the magnitude of this? Root of x square plus y square plus z square. The same thing you got here, right? Alright. So in spherical polar coordinate system, to represent a point, we need 3 parameters. One r, theta, phi. Now, how these points vary? That also important. See, for a sphere, this r, you can choose any size of sphere, right? Then r may vary from 0 to infinity. Alright. Now what about pi value? What about theta value? theta, see this theta can vary from up to this only, right? This is this axis, z axis. So it can vary 0 to pi. If the point is here, we choose then this is our theta we choose from here only. So up to this only we can choose. If theta, the point is lying here, then we take theta in this direction only. The maximum value of theta is 0 to pi. The theta value is varying from 0 to pi. Then phi value, so this point is, see look here, this point, this is phi, right? Now this phi, it can rotate like this only, then 0 to 2 pi, 0 to 2 pi. This is the range of r theta phi, that is very important. So in the next I will show you some figure, right, to see, look here. This is a sphere of radius r. Sphere of radius r is given. Then what is the value, right? Different range. R is varying from 0 to r because radius already given. 0 to r by 2 come, r by 3 by 4 r coming, and finally 0 to r. Now what is the theta? Theta value, if this is the axis, 0 to pi. Phi value, this angle, that is 0 to 2 pi. Now look into hemisphere. Hemisphere, this theta value, this much only changing, pi by 2. Then theta value varying from 0 to pi by 2. Radius of the hemisphere is r, means r is varying from 0 to r. Now phi vector is changing like this, that means 0 to 2 pi. Alright? Alright. Now another figure given. Here, see look here. Here we given one quadrant only, right? So look here. Here this is the theta variation. So this is 0 to pi by 2. This is 90 degree alone. Right? So theta is varying from 0 to pi by 2. What about phi? Phi is varying from this point to, this is phi value, up to this only. So above that we need not move because one quadrant only we considered. So this also pi by 2. This angle also pi by 2. This angle also pi by 2. Right? And already the given radius r, then r is varying from 0 to r. Alright? Now this is a cone. Any point you take here, this radius r only. Any point, this from the origin, this distance is r. Right? So radius is varying from 0 to r. Alright? And theta, this theta is varying from, see here also you take this theta about this axis. Any point here you take, this theta is this semi-vertical angle about this axis, that is 30 degree, that is pi by 6. Alright? And here this phi, look here, this rotation is 0 to 2 pi, right? This angle, then only this point may mark here, 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 here. So this point should be rotated like this. Alright? So in this figure, 0 to 2 pi, right? Phi representing 0 to 2 pi, theta representing 0 to pi by 6, r representing 0 to r. Right? Now we need to represent the area element, volume element, length element in spherical polar coordinate system, right? Alright. Okay, so look here. Here one part of a sphere, actually this is a full sphere, right? I extracted a small volume from this sphere, right? So you know, suppose this is my point, right? This is my point. Let me use another color here. So this is the point, right? This point, first I am considering this point is r. Alright? This length is r. So r I defined radial vector r. Now that radius vector making the axis of the sphere angle theta. Right? and that base vector, see this is that point is lying here on the surface, that perpendicular makings an angle. So suppose I am making a perpendicular, this is that angle phi, right? Now see, look here, I am considering we created a volume in Cartesian coordinate system. How a dx increased in the x-axis, a dy increased in the y-axis, a dz increased in the z-axis. Similarly, this theta, I am increasing a small d theta, then this much length increasing, right? This much length increasing. So I am using another color here, right? Okay. See, this much length I am increasing because I am increasing a d theta here, right? So this length is increasing here. What is this length? This length is r, this length is d theta, this arc length is r d theta, correct? R d theta, alright. So this length I can represent as r d theta, alright. So I am representing this length is what? R d theta, alright. Now similarly, I am increasing a small d phi here. Already we studied this is r, then this is r cos theta, and this is r sin theta, right? This is r sin theta. Then what is this length increased here, right? Because this d phi I am increasing, so this is that, right? So what is radius here? R sin theta, r d phi, but here r is r sin theta, then r sin theta d phi increasing here. That means this length, right? This length is parallel to this, then this is length is r sin theta d phi, r sin theta d phi, alright. Now what is this r I am increasing, this is the point, r I am increasing in this direction, the dr increased here, right? So now what I have done is, I taken r theta phi, a fixed point, then a small d theta, a small d phi, a small dr I increased. Because of that increasing, this part is increased, this part is increased, this part is increased. There we created a small volume. This is that volume, right? Now let us find out what are the increasing parameters. So a small length I increased, dl is equal to dr r cap, in the direction of r cap dr I increased. In the direction of theta, right, r d theta I increased, then r d theta theta cap, alright. And in the direction of phi I increased r sin theta d phi. Direction is phi cap. Phi cap is the unit vector. We tell dx I cap plus dy j cap plus dz k cap. Similarly, here dr r cap plus r d theta theta cap plus r sin theta d phi phi cap. So this is the length element representation in spherical polar coordinate system, right? Now how we can represent area, right? How we can represent area, right? So I am considering this area. How we can represent area, right? That particular area I am representing. So this length is r d theta, right? It is parallel to this. So area, small area element I can represent this r d theta into this length, that is this length, right? So that means this length into this length, that means r d theta into this is r d theta, and this is r sin theta d phi, r sin theta d phi. Then what is dA? dA is equal to r square sin theta d theta d phi, d theta d phi, right. Now volume element, right, area into height. What is height? This is the height dr. What is area? We already created. Then dV is equal to, that is volume element, that is dA into height. That is, what is dA? r square sin theta d theta d phi into height. Height is this, that is dr. What? dr. That means dV is equal to r square sin theta dr d theta d phi, r square sin theta dr d theta d phi, right. So now we got how we represent a length element representation, area element representation, and volume element representation, right. So let me express that in a different way. So what is length element we represented? dr r cap r d theta theta cap plus r sin theta d phi phi cap. Alright. What is area element we represented? r square sin theta d theta d phi, right. What is volume element we represented? r square sin theta dr d theta d phi, right. Now look here, let us check how this work out. See, if this is a small area representing, if that answer is correct, by integration we got the complete area of the sphere. What is complete area of the sphere? 4 pi r square. Let us check. You integrate this. That means integral dA is A. A is equal to, integrating this r square, right, we can take out sin theta d theta on integration. So integral theta is varying for a full sphere, theta is varying from 0 to pi, right. Theta limit sin theta d theta, and phi is varying from 0 to 2 pi, that is d phi, that is r square into minus cos theta 0 to pi, and d phi, that is phi 0 to 2 pi. Now r square into cos pi minus 1, then minus 1, minus 0, cos 0 1, then this is 2. Here upper limit you give 2 pi, that means 2 pi into 2, 4 pi r square, right. So we know this is the sphere surface area. So this is the areal element. Now by integrating these, you are getting volume or not. You know spherical volume of a sphere is what? 4 by 3 pi r cube. So what is integral dV? That is equal to, right, integral, here r square dr is there, then r square dr into integral, here sin theta d theta. So this is varying from 0 to r, this is varying from 0 to pi sin theta d theta into integral 0 to 2 pi d phi, right. So this on integration r cube by 3, right. This on integration minus cos theta 0 to pi, that is 2, and d phi on doing phi 0 to 2 pi, 2 pi. Then what you got here, limit you apply 0 to r, then r cube by 3 into 4 pi. That means 4 by 3 pi r cube, right? So you got the volume of the sphere, alright. So this is the length element representation, this is area element representation, this is the volume element representation in spherical polar coordinate system, right? Alright. So this is about the spherical polar coordinate system discussion, and in the next class we discuss about a cylindrical polar coordinate, right? Alright. Thank you.